This class we study about the SR latch. SR latch. So what do you mean by latch? A latch is a basic storage element. Is called as a latch, and it suggests that it will latch between 0 and 1. It is a storage element. Latch is a storage element. So it can be realized by using a NOR gate or by using a NAND gate. I hope you know the truth table of NOR gate and NAND gate. If not, I just revise you. Say a NOR gate is nothing but an OR gate with an inverted input. A NAND gate is nothing but an AND gate with an inverted in the output. So in this one we can see an inverted output here, and we can see an inversion here. So what are the value which we give in this A and B? It will OR means it will plus, and then it will invert the result, and this result we will be getting as a output. That is why output as y. So here whatever the result which you are getting A and B, it will multiply and it will invert, and here we get the output. It will invert, and after the inversion you will be getting the output. So we see about the SR latch. So this can be implemented by cross connecting by using the NOR gate. First we see about the NOR gate, implementation of SR latch using the NOR gate. SR latch using the NOR gate. So this can be implemented by using a NOR gate connecting in this way. So this we call as R, and this we call as S. Yes. So two parallel NOR gates, the output is being the input of this one, and the output of this one is being the input of this one. So we are having the two outputs, that is 1 and 2. This we call as Q and Q complement. The second output will be complement of the first output, and this is the implementation by using the NOR gate. Now we study by giving the different inputs, that is by giving 0 and 1 alternatively to R and S. So what are the different combination which we can give here? That is, we can give 0 0, R and S as 0 0, 0 1, 1 0 and 1 1. These are all the following inputs which we can give to the RS, and we need to see what will be your output, and we also need to ensure that whether this latch is being performing its basic function, that is, it is storing the data. Okay, fine. Next we see about this one. So I will just write down the NOR gate truth table so that for you understanding purpose. Say for A and B is here, and for Y, so both input are 0 0 1 1 0 1 1. When for a NOR gate is 0 plus 0, that is 0 0 complement, that is 1, 0 plus 1 1 1 complement, that is 0, 1 plus 0 0, 1 plus 0 1 1 complement 0, 1 plus 1 1 1 complement 0. So this will be the truth table of the NOR gate. So that is, if the input is higher, the output will be 0. if any one of them, we can see if any one of them is higher, then the output will be 0. When both input is lower, then only the output is higher. So now we just see this NOR gate by using the SR latch. NOR gate SR latch implementation using the NOR gate. So what is the difference between latch and a flip-flop? A latch doesn't have any clock pulse, and flip-flop will be having a clock. So that is why we study about first latch, SR latch. For NOR gate, you just draw the NOR gate, and here we are having this one NOR gate. I have drawn a NOR gate here. So from this one, I taken this one as R, and I take this one as S, and then you take this one as the complement, and this one as complement to this input. Then take this one as Q, then take this one as Q complement. The next one, so this is the implementation of RS. So I think you remember this one, or you just write down this NOR gate. I am just rubbing it out for if I put both R and S here, R, S, and next I need to know about Q and Q complement. These are all the things which I want to know now. What happens if I give these inputs? Say I give R equal to 0 and S equal to 1. What will be the output? I have given R equal to 0 and S equal to 1. What will be the output? So first what it does, for any 0 input, if the input is higher, if input is 0, what will be the output? Output will be higher. So that is, it will becomes higher. See here, it follows like this. We are given 0 here, so 0 complement, it becomes 1 first. Then this Q will be 1 here. This Q1 will be given to this input. So here already higher, 1 into 1. 1 into 1 is 1. 1 complement, that is 0. 1 complement is 0. So that we get here, for R equal to 0 and S equal to 1, Q equal to 1 and Q complement is equal to 0. Then what I did, then I have made this, just rub this one. Say I just rub this. Say this will be 1, and you just remember this output as 1 and this output as 0. Next I have changed this R, S input. So here I have given R equal to 0 and S equal to 1 here. Then I got this output. Then what I did, then I have made S equal to 0. Then I have made S equal to 0. Then you can see that the Q complement output is 0 and Q output is 1 here. Q output is 1. I have just made the S input as 0. S input as 0. Then what happens here? This 0 will be fed to here. This 0 will be fed to here. This 0 will be fed to here, and 0 into 0, it is 0. 0 complement, it will be 1, and 1 is fed to here. 1 into 0, so this will be 1. See, so 0 plus 0, not 0 into 0, 0 plus 0 is 0. 0 complement, it is 1. Then if 1 is fed to here, in this one, 1 plus 0 is 1. 1 complement is 0. Once again, for 0, 0, For 0 0 the output will not change. So this we call as the memory. This we call as the memory. This is the memory. This is the memory stage. Memory. This is the memory. This is the memory. Then I have made r equal to 1 and s equal to 0. Then I need to know what happens if r is equal to 1 and s equal to 0. I am just rubbing the remaining things. Just let me rub everything. Then I have made r is equal to r and s here, and put one latch here and one more latch. See here, one more gate here, NOR gate. This output will be the input, this output will be its output. So this will be q and this will be q complement. So what happens here? When I have put r is equal to 1, r is equal to 1, there I have put r is equal to 1, r is equal to 1 here, and s equal to 0. S equal to 0. So what happens if the input is higher? What will be the output? Output will be lower. See, it is lower. Input is higher. The output will be lower. So this lower output is being fed as an input to the S gate. So this 0 is being fed here. 0 plus 0, that is 0. 0 complement, it is 1. So for this one we are having it is 0 and here it is 1. Then suddenly I have changed r input as 0. R input as 0. R input as 0. Then what happens? This 1 is being fed to here. This 1 is being fed to here. 1 plus 1. This 1 is being, this 1, 0 and 1 I am not changing. I am just changing the input as 0. Then this 1 q complement 1 is being fed to here, and this 1 plus 0 is what? 1. 1 plus 0 is equal to 1. 1 complement, it is 0. Fine. I hope you understood. I am not changing the q complement and q value. Please be careful. I am not changing the q complement q value. This change avunilla. This value will not be changing. I am just going through this one. See here, I will just rub once again and I will show you. Once again I will show you. Once again just show you. For this r is equal to r is equal to 1. See, for r, rs, rs, this is q, this is q complement. So what happens here? Q is 0, q complement, q is what? Q is 0, q is 0, q complement is 1, and I have changed this. Already it is 1 0. For 1 0 it is yielding as 0 and 1. Then I have changed this 1 to 0. 1 to 0 here. I have changed 1 to 0. Then what happens? This input, this output I am not changing. That is 1 will be its input here. 1 plus 0 is what? 1. 1 complement, it is 0. Correct. Then 0 plus 0 is what? 0. 0 complement, it is 1. So the output never changes. For 0 0, if you give, the output will be 0 1. This stage we call as the memory. This both stage we call as the memory stage. Memory stage. Memory stage. This both stage we call as the memory stage. For 0 0, if we give input, the output will be it records the previous input, that is 1 0, that is 1 0. If it is 0 1, it will recall about the 0 1. Okay, then the one more interesting thing comes here. What happens when r is equal to s equal to 1? R is equal to s equal to 1. So this is very important condition. When r is equal to s equal to 1, say I am drawing a latch here. I am drawing a latch here. Q complement r and s here. When r is equal to 1 and s equal to 1, what happens? 1 complement is what? 0. Then 0 plus 1, that is 1. 1 complement is 0. So it is alternatively it becomes 0 0. This is not an advisable, because the output of the 1, if it is 1 then it should be 0. If it is 0 then it should be 1. When both should not be 0, it is not recommended, it is not allowed. That is, both output cannot be simultaneously 1 or both output cannot be simultaneously 0. Both outputs should not be at a time, should not be 0, or at a time it should not be 1. Either it can be 0, this output can be either 0 or 1. Here it should be 0, here it should be 1, or here it should be 1, or here it should be 0. But both you cannot say, you cannot consider, you cannot accept both as 0. You cannot accept both as 0. This is not acceptable. This is not acceptable. Say if I have changed this one has 0, when see for 1 1 r is equal to 1 and s equal to 1, I am getting q and q complement. Q and q complement as 0 0. Fine. What I had, see, let us see, I have made this one as 0 0 here. Whether this 0 0 is stored here, let us check whether it is storing 0 0. I am just making this input as 0 0. Simultaneously I am making this input as 0 0. Whether it is storing the input. See here, 0 is being fed to here, 0. So what happens? 0 plus 0, that is 1. 0 plus 0, 0. 0 complement, it becomes 1 here. It becomes 1 here. Becomes 1 here. So 1 plus 0, that is 1. 1 complement, it becomes 0 here. So it becomes q as 1 and q complement as 0. When I have taken in this respect, when I taken from here, when I have taken from here, it is 1 0. When I taken from here, it will be 0 1. It will be 0 1. That I show you now. That I show you now. See, I have taken this one as s equal to 0. S equal to 0. 0 complement, it becomes 1. So 1 which you have fed here, 1. 1 plus 0, that is 1. 1 complement, that becomes 0. So here it is 1, here it is 0. So this 0 1 1 0 is not acceptable. So this type of range it generates, it is, that is, the memory is not being stored here. Memory is not storing this 0 0 also. 0 0 ഇത് 1 1 കൊടുത്തിട്ട് 0 0 ആണ് കിട്ടുന്നുണ്ട് എന്ന് പറഞ്ഞു കഴിഞ്ഞാലും ഇത് മെമ്മറിയിൽ നോക്കുമ്പോൾ ഐദർ 1 ഐദർ 0 ഐദർ 0 ഐദർ 1 അങ്ങനെ അത് ഓസിലേറ്റ് ചെയ്ത് കളിക്കുന്നുണ്ട്. അതുകൊണ്ട് യു കനോട്ട്, സോ ദാറ്റ് പർപ്പസ് യു കനോട്ട് ആക്സെപ്റ്റ്, ദാറ്റ് ഈസ് ഫോർ RS latch this condition, that is 1 1 condition is not acceptable. So 1 0 1 1, for this one is we call as the memory, and this is not allowed, not allowed. Okay, the 1 1 is not allowed, and 0 1 and 1 0. For 0 1, if I give r is equal to 0, then it becomes the reset. reset, then it becomes set, so memory reset, set not allowed. So these are all the conditions to be followed for an SR, but NOR, realizing the SR latch by using the NOR gate. Okay, I hope you understood this truth table and all, and we just see in one more gate by realizing the SR latch by using the NAND gate also.